Welcome to a lesson on properties of tangents to circles. Let's say we have a circle here, and then if we draw a line that intersects the circle at only one point, then that line is called a tangent to this circle. So if we draw a line, let's say this line here, which intersects the circle at only this point, let's call this line AB. Say this is line AB. Now, if this line AB intersects the circle at only one point, or if it touches the circle at only one point, then this line AB is called the tangent. So this is the tangent line. Now, the point where the tangent line and the circle intersects is called the point of tangency. So this point here is the point of tangency. Now let's explore some properties of tangents to circles. In this video, we will look at the tangent radius theorem. The tangent radius theorem states that a tangent to a circle is perpendicular to the radius drawn from the point of contact. This theorem means from this point of contact between the tangent line and the circle, if we are going to draw a radius, then this tangent will be perpendicular to this radius, which means the tangent line and the radius are going to intersect at right angles, which means 90 degrees. If we let this point of tangency to be P, and let's say the center of the circle is O, then in summary, this theorem means if OP, the radius, is perpendicular to the tangent line AB, this is the line AB, then this angle here, OPB, will be equal to the measure of this angle here, OPA. They are both going to be 90 degrees because perpendicular means intersecting at right angles. So this is what this theorem is saying. In other words, we can say the angle between a tangent and a radius is 90 degrees. We have seen here the angle between the radius and the tangent is 90 degrees. This theorem can help us determine the measure of missing angles and the length of missing sides of right-angled triangles. Let's see some examples. This question says point O is the center of a circle and AB is a tangent to the circle. AB is a tangent to this circle. In triangle OAB, the measure of angle AOB is 54 degrees. Determine the measure of angle OBA. We need to find the measure of this angle here. Now, what do we know about a tangent to a circle? Well, we know that when we have a tangent line and we have a radius drawn from the point of contact, then the angle between the tangent and the radius will be 90 degrees. So the measure of angle OAB will be equal to 90 degrees. Why? We can say this is because of the tangent radius theorem, which means a tangent and a radius intersect at right angles. Now, in this triangle, we have the measure of this angle is 90 degrees and the measure of this angle. Now, to find the remaining angle, we just add all the angles. We know the sum of the angles in a triangle is 180 degrees, then we can find the missing angle. So we are just going to take this angle here, angle OBA plus 54 degrees plus 90 degrees, and the sum will be 180 degrees. The reason here is because of the angle sum in a triangle. Now here we have angle OBA, 54 degrees plus 90 degrees is going to be 144 degrees, is equal to 180 degrees. Now to get OBA here, I'm going to subtract 144 degrees from both sides of the equation. Then we're going to have OBA is equal to 180 degrees minus 144 degrees, which is going to be equal to, we just subtract there, we get 36 degrees. So the measure of angle OBA will be 36 degrees. Let's look at another problem. This problem says point O is the center of a circle and PQ is a tangent to the circle. PQ is a tangent to the circle. PQ is 12 centimeter. PQ is 12 centimeter. And OQ is 13 centimeter. Determine the length of the radius OP. The length of the radius OP. Now again here we can see that a radius is drawn from the point of contact of a tangent line and a circle, which means the angle between a radius and a tangent is 90 degrees. So we have a right-angled triangle because this angle here, angle OPQ, the measure of angle OPQ is equal to 90 degrees. So we can say, again, this is because the angle between a tangent and a radius is 90 degrees. Now we have this right-angled triangle. 13 is the hypotenuse of this right-angled triangle. Then we can just apply the Pythagoras theorem. Then by Pythagoras theorem, if we take the length OP squared plus this length here, PQ squared, we are going to have the length of the hypotenuse squared, OQ squared. OP, we are not given the length OP, so OP squared plus PQ. PQ is 12, so we have 12 squared is equal to OQ squared. OQ is 13, so we have 13 squared. So here OP squared plus 12 squared is 144 equals to 13 squared. 13 times 13 is 169. Then to get OP squared on this side, I'm going to subtract 144 from both sides of the equation. Then I'm going to have OP squared equals 169 minus 144. Then OP squared is going to be equal to 169 minus 144 is going to be 25. Then to find OP, I'm going to take the square root of both sides. Then the square root of OP squared is just OP equals to the principal square root of 25, which is 5. So OP, which is the length of the radius of this circle, is 5 centimeters. Hope this helps. I will see you again in the next video.